Dealing with testing fatigue. Welcome to my talk. I'm Fabian Schmengler. I'm from the German agency Internet. I'm testing Magento for a while now and like to talk about it. But did you know that TDD is dead? So according to this blog post from David Heinemeier-Heinzen, the inventor of Ruby on Rails from 2014, it is. He started quite drastically with test-first fundamentalism is like abstinence-only sex education. An unrealistic, ineffective morality campaign for self-loathing and shaming. That sounds bad, doesn't it? And I do like test-driven development. What's wrong? This post spawned some interesting discussions between him and Ken Beck and Martin Fowler as big proponents of test-driven development. And they didn't quite come to an agreement, except that they agreed to disagree, and for some people test-driven development works and for some it doesn't. But they all agreed that automated testing in itself, first or after the fact, is important. That's the second part of the article, long-lived testing. What I'm hearing a lot, especially in the Magento community, is something like, I'd really like to write more tests, but I don't get any practical value from them, so I stopped doing it, or I don't enjoy it because it takes too much time or it is too hard. And to be honest, I can relate to that. I know the feeling. Another popular opinion is integration tests are superior to unit tests, so don't waste your time with unit tests. Well, at least these people are writing tests. I still tend to disagree. But there's some funny memes like this: 2 unit tests, 0 integration tests. If you search for it, you'll find many pictures like this where something works isolatedly, but if you put it together, it somehow is wrong. Again, a bit more drastically, here's a picture of the Titanic with passing unit tests. This was also.
I hope you enjoyed your food.
Yeah, no, I don't. Go away.
Front-end, we have Gabao Semelius. He's talking about innovative commerce. That's front-end. In back-end,
if you want to go there, it's over there.
Dealing with testing fatigue.
That's me.
On the main stage, we have Antonia Tadic. Correct? And she's going to talk about a galaxy far, far away where the project manager is Magento 2. Okay, please welcome her warm. Give her applause. Oh, no.
Thank you. Okay, thank you. I'm just going to continue. What do we have here? Yeah, things are mostly fine. But somehow nobody did test the whole ship. But let me say it like this: if you want to test the light bulbs, you shouldn't need the whole ship. So why all the frustration? I was trying to find some typical problems in tests and offer solutions for this talk. And while doing research for it, I found out, like as with everything in software, it has been already done decades ago. In this case, there's a book, X-Unit Test Patterns from 2007, so technically decades ago, which contains a whole section about test smells. A smell tells you that something's fishy. And these smells are categorized in project smells, which can be observed on the project management level, behavior smells that can be observed while running the test suite, and finally code smells that can be observed when looking at the code. The project smells are, for example, buggy tests. A test that passes when something's wrong or fails when everything's right. There's a bug in the test. Or high test maintenance cost. If you spend lots of time working on your existing test suite, or production bugs. If you have lots of bugs in production, your tests didn't do a good job in finding them. And finally, developers not writing tests at all. The common excuse for this is they don't have time. I don't think that's true. More likely, they don't have the skills and don't get time to learn. Another reason might be that the software design doesn't support tests well. It's not very testable, which shouldn't make testing impossible, but it makes testing really hard. Or maybe you choose the wrong test automation strategy for the project. The behavior of Smurfs can be fragile tests that a test breaks without a real reason, because you changed something somewhere else, and another test fails because some interdependency, but not because it found a bug, but because there's something wrong in the test, something that has to be changed in the test. Or erratic tests, tests that sometimes fail, sometimes pass, dependent on the environment, or dependent on the order in which the tests run, dependent on the phase of the moon, whatever. Most of the time you don't know. Then slow tests. If you have to wait for hours until the test suite ran, you don't get the fast feedback you need as a developer if what you have written is right. If you find yourself frequently debugging, it's also a smell, because usually your test should tell you where exactly something's wrong. And if you always have to debug step by step in your code, your tests didn't do a good job in that. Finally, manual intervention. If you can't fully automate your tests, you need some manual steps in between or beforehand to prepare. About the code smells, we'll come to that later. Those are usually the root causes of these smells. These ones are really the frustrating ones. And yeah, if that sounds familiar, you're like me, I've been through all of it, and somehow this guy pops up in almost all of my Magento presentations. I don't know why. Well, what to do about it? I could crawl under my desk and cry and give up, but that's not what I choose. There's a way out, but I have to warn you, it's not an easy way. Because first you have to learn. Testing is not the same skill as coding. So that's the bad news. It takes time, it takes experience. You are not there from the beginning, can't just start doing it the right way. And how do you learn? Well, there's lots of books and blog posts and conference talks. You can learn by practicing with, for example, katas or dojos. These are small exercises that you do repeatedly to learn the style of test-driven development or the different types of testing. And maybe you can learn on a small project, not immediately on a big Magento project where everything is difficult to test. Then, test the right things. And in my opinion, everything is not the answer. For example, you shouldn't need to write a unit test for each class. There are some dumb classes that don't need unit tests. Or a unit, and now I'm saying something blasphemic for some people, is not a class. Find some sensible boundaries for classes that work together and test this together as a unit. Then, besides unit tests, you need other types of tests, integration tests, functional tests. Use a healthy mix. And if you covered something with one type of test, you don't need to cover exactly the same thing with another type of test. So, general rule, which is harder than it sounds, is always ask yourself, are these tests really providing value? Will they provide value in the future? And if they don't be afraid to delete them. If they just cause maintenance work and don't find bugs anymore, don't help you refactoring anything. Another important point is write testable code. That's a big topic. And in Magento you could say, but it's not testable, I have to work somehow with it. If code is hard to test, aim to make it easy to test. That's, again, more difficult than it might sound. And I'll throw in some keywords here, but I won't focus that much in this talk. Dependency injection is an important keyword for testable code, and if you're working with Magento 2, you're all used to it already. Dependency inversion as well. It tells you to depend on abstractions. So as a general rule of thumb, if possible, depend on interfaces and not concrete classes. Another keyword that could fill a whole talk is ports and adapters. So basically this is about decoupling your business logic from the framework code and from the infrastructure code so that you can test it on its own. But in this talk I'm more focusing on improving the test architecture, because that's something that it's not talked so often about. I'll show you some code smells, the things that that don't work so well in tests, and some possible solutions and patterns. Before, let's start with some basic terminology and how a test is structured. A test usually contains of 4 phases. The setup, where fixtures are set up, that is, objects are instantiated, or maybe something in a database is prepared. Then the exercise phase, where the test interacts with the subject under test. The verify phase, where you do your assertions. And finally, if necessary, the tear down phase, where you clean up after your fixture. There are different strategies for fixture fixture setup. A pre-built fixture is, for example, the Magento integration test database, something that is created before all the tests are run. Then there are shared fixtures that can be shared by the whole test suite or shared by one test case. And finally, fresh fixtures that are set up for each test again. That could be inline directly in the test method or implicitly in a setup method of a PHP unit test. The big advantage of these is you have less side effects. You always start with a fresh object and it doesn't influence another test. A disadvantage in using it all the time is, of course, performance, especially in Magento, where you have some complex setup. It's not feasible to instantiate Magento again for each method. Although that would save us lots of trouble, it would take too long. So let's start with some testing smells. The first one should be obvious. It's copy and paste. So if you have duplicated logic in test code, that's somehow wrong. An example from Magento is the customer fixture script that sets up some customers for integration tests. There's a file, customer.php, I don't know if you can read this, which contains some spaghetti code, to be honest, to create a customer. Then there's a file, toCustomers.php, which contains the same spaghetti code twice. With different email addresses. And then there's 3 customers.php and 21 customers.php. You can imagine how those look. And no experienced and sane developer would do this kind of code in production. But somehow, really skilled architects and programmers in Magento thought that it would be fine for tests. To be honest, I've done these things too. So, somehow it's typical to not care about test code the same way as for production code. And it's not only for fixtures, it's also for blocks of assertions that are copied around and only with the small changes from one test method to another. What's the problem with it? Same as in production code. The cost of changes increases. If you need to change something, for example, if a customer gets a new required attribute, you don't have to change it in one place, but in 21 places, and that's only one file. The solutions, luckily, are the same as in production code as well. There are some refactoring methods. You can extract a method. So in the setup phase, a method that creates something and that we call repeatedly with some parameters. Or if you access some shared fixture, find a method that finds this fixture. In the verification step, you can write custom assertions. And if the duplicate code happens to be across several classes, you can extract a class instead of a method. For the setup, there's a nice pattern, the test data builder, which I'll come to in a minute. And for verification, there are custom constraints. In PHP unit, you can create a constraint by extending the PHP unit constraint class and implement two methods. One is matches that tells you if the constraint evaluates to true. And one is the failure description, which shows what PHP unit will display when it fails. So here we have a simple constraint, is meaning of life, which of course is only true if the value is 42. And it can be used with the assert that method. So you'll have this, assert that 42 is new meaning of life. Usually you will have some constructor parameters for the constraint, so it doesn't test the exact same thing all the time. Now for the test data builder. A builder is some kind of configurable factory. A class that you can configure, and then you get an object from it. And for test data, this builder creates some fixture, and it's reusable across tests. I'll show you an example with the customers again. This is how it could look like. You have a customer builder with a customer constructor, which gives you some default customer. But then you configure it before actually creating it with some relevant data for the test. So here we'll choose which email it has, test@example.com, and some custom attributes, and you build it. And I started to create a library for Magento 2 for exactly these things. Check out this link. I'm going to tweet all this later, so you don't have to write it down now. It's really nice. And it also solves a different problem. And that's the irrelevant information smell. If it's not clear what in the test setup or in the assertions is actually relevant for the test. Here's again an example from the Magento integration test fixtures. I already shortened it, but it still barely fits on the screen. This is for a test that tests the reset password token. And the only thing that's interesting for the test is the two lines in the bottom, which you in the back can't see. It sets the reset password token and created add timestamp. And maybe the customer ID at the top could be interesting as well. The rest is just noise because the customer needs these required attributes, but they are not relevant for the test. Why is it the problem? It's hard to understand, hard to read, and especially if you want to treat your tests as a documentation, what the code is doing, it's almost impossible. So in this case, test data builder would have solved the problem. You would have requested a default customer and only set the reset password token. Or in general, you can extract methods or assertions with the relevant parameters and hide the irrelevant stuff somewhere in these private methods. The next smell is hard-coded test data. Here we have an example where something returns a timestamp, and then you have an assertion about the timestamp. Doesn't matter what it does. Now this timestamp is recognizable as a timestamp. You see it directly below each other, so the problem is not that big. But often you have test methods that are way longer, and so you instantiate something at the top and assert something at the bottom, and the connection is not quite clear. What makes the problem worse is that most developers are not very creative in inventing test data. So you'll see a lot ones and zeros and foos and bars and 42s, and it's not quite clear what it stands for. So it's hard to understand cause and effect. Possible solution is introduce variables or constants that that tell the reader what this value means and which value is connected to each other. The next smell is the mystery guest. The mystery guest is when something in the setup or in the verification relies on information that's not visible in the test but lies somewhere else. That could be a file or something in the database or some general fixture that are shared between several tests. I'll show two examples. This is again from Magento, a test about the product import, and it imports a CSV file that lies somewhere in a different direction within the test. And then later, it makes assertions about the values in this CSV file. Another example, this is the database record and general fixture example. Here we have this Magento data fixture annotation. which loads one of these fixture scripts from Magento, which lies in some different directory and is shared by several tests. And this is a viewed products PHP. It's a long procedural script, and it includes another long procedural script, which includes another long procedural script, which then creates a product with a name simple product. And in this test, we then assert that in some response, the text simple products appears. But to understand that this is the name of some product that has been created, to understand this, we have to go through many files which are somewhere completely different, in a different place. So again, the problem is that it's hard to understand cause and effect. And especially for these shared fixtures, there's an additional risk if somebody edits this file or this resource without knowing how it's used elsewhere, well, it probably will break. Or nobody dares to touch it anymore because you don't know what breaks. So there are different possible solutions depending on what we're dealing with. A good solution would be to have a fresh fixture for each test and not share so much. Then test data builders again do a good job instead of using these scripts from Magento. If you're dealing with files, create the files directly in the test, if that's feasible. If not, because I don't know, it's a big binary file, at least keep it next to the test and not in some completely different directory. So you can look at it together and like if you create the file in the test, you can again use variables while creating the file and then use the variables in the assertions so it's clear what's connected to each other. And if you have to use a shared fixture, at least use some accurately named methods to access it. So let's say we have a product. Thank you. Product in the test case.
Thank you very much, Antonia. Chciałbym teraz zaprosić Was na...
Is the time already over?
Ale to jeszcze tylko powiem, że back-end mamy Łukasza Romanowicza z Obry,
I'll let him talk.
który będzie mówił o monitorowaniu logów. Jak również mamy Anna Karoń, która będzie mówiła o Accessibility Workshop. A teraz będziemy rozmawiać o case study apteki internetowej i na scenę będę zapraszał panią Małgorzatę Pawłowską i pana Filipa Krasińskiego z Hardcoded. Przywitajmy ich brawami.
Thank you, so that means it's over. Okay, that should give me a minute at the end. Where were we? So we have some, or instead of having some thing that is shared between several tests and it's called product, if we have to reuse it, at least access it with a method like get recently added product, because we are interested in this aspect of the product and making clear that this is something that we rely upon. Not the best solution, but better than just accessing something generically named. Next test, the eager test. This is a test that wants to verify too much. So in this example from Magento, we have a test about stock items, and it tests several steps, one after each other, one test method. That's changing the quantity from null to an integer greater than 0, then changing it back to an integer to 0, and then changing it back to null. And why is that a problem? It's hard to tell apart where the setup, exercise, and verification happens, because it's all mixed and not in the right order. And it's harder to localize defects. If this test fails, you don't know what part of the test still works and what does not work, because it fails at the first failure, and you don't know about the other cases. Solution is easy. You have single condition tests. So about this hard to tell apart setup, exercise, and verification, I have another testing pattern that I learned to like. It's a bit taken from the behavior-driven development. That's having high-level test methods, which also only call methods starting with given, when, or then. So a test like the one from before would read, given stock item with quantity 2, when stock item is changed to 0, then loaded stock item quantity should be 0.000. So these high-level test methods make very clear what exactly we are testing. And it's also clear where the setup is, where the exercise is, and where the verification is. If the tests get bigger, this is not always clear if you have all the implementation details in them. Of course, you have to convert variables like the saved stock item that you use in all of these to properties of the test class. You can also have multiple setup methods or multiple assertions, and then it's nice to start these additional ones with end, so it reads even more like natural language. So you would have then loaded stock item quantity should be blah blah blah, and something else. Now this smell is something that you'll find often in unit tests, especially in the Magento core, excessive mocking. In this case, you'll have to write, I think, 3 mocks with 7 methods just to have some store with 2 currencies and a conversion rate. And the problem is you're coupling your tests very close to the implementation, which makes it almost impossible to refactor the code. And unit tests should help you refactor the code and shouldn't care so much about how the code is accomplishing something. And if you change something of the details, and then you have to update the tests because all the mocks must change, you lose this value. Also, the test is hard to read. If you look at this, what does it do? So unfortunately, you'll find this very often in Magento because there are no really simple domain objects like a currency rate would be. They depend on everything imaginable. A good solution would be to use real domain objects in the tests and not use the mocks. With Magento classes, that's often not possible. So my usual advice would be to refactor the production code to make it more testable. If it is Magento, yeah, of course, you can make a pull request, but don't try to make a pull request with such a drastic change. So you'll have to find a different solution. That could be using some adapters instead of the real Magento code. Or at least write some more easy-to-use stub or fake objects instead of the mocks that PHP unit provides you with. I have a simple example for a fake object. A fake object is an implementation of an interface with test-specific properties and without any external dependencies. So for example, let's say the customer session has an interface where the method is logged in. And the real customer session, of course, has dependencies to the session, maybe in the database and things you don't want in your unit tests. Then there could be a fake session, which simply returns a property logged in when is logged in is called. And you can add some methods specifically for tests, which changes the value, and you could call it login and logout, which makes a really nice interface, because if instead of creating a mock with PHP unit and tell them if this method is called, return this, you create a fake session and call a session login, which is much more clear and succinct, and you can also reuse it across tests. Now this is one really tiny method, but of course you can do the same for more complex classes and methods. Now the next smell is meaningless test names. I often find something like test case 1, test case 2, test case 3. Now, what if one of these fails? What does it tell you? Case 2 is broken, now what? So failures in tests are unclear. You don't know what's broken without inspecting all the code. So the solution is obvious, write meaningful test names. I know names are hard, but it's really important and valuable. So take some time to give your tests names that tell the reader immediately what is tested. If you use data providers in PHP unit, you can also use a string key for each of the data sets, so you won't get a result like data set 1 failed, but dataset meaningful description of case 1 failed. Very similar are meaningless assertion messages. I often see something like failed that 1 is 0, or failed that false is true. This tells us nothing. Again, with developers not being very creative with test data, it's always 1 and 0 and foo and bar, so it doesn't get better. And if I run the test in my IDE, I can just click there, and if the tests are well written, I will understand what's wrong. But what if I get a test report and don't have direct access to the code? For example, from continuous integration server. So solution is to always use the message parameter in assert methods and describe what you are expecting and why. One final smell for today is the conditional test logic. Let's get this straight. Don't write ifs in tests. Never. This is something from Magento again. I left out everything except the conditions because it's a huge test method which tests some email sending. And well, somebody tried to be clever and used the data provider to set different config flags and test everything in one test method. Now, who's going to understand the test? And even worse, it's hard to write this test correctly. In the end, you will need a test for the test. And who wants to write this? So a solution for something like this would be to have a separate test method for each of the combinations. And to avoid duplicated code, then extract the duplicated code to our methods instead of having some if conditions. If you have conditions in your test because you don't know exactly what happens and just want to be sure that, that the test works, don't. Make sure your tests are deterministic. It's always possible. Now there are more smells that are worth looking into. I don't know if I have a few minutes left to go through them. Somebody here showing me time? No? Just real quick, if you have test logic in production, like you check some flag, if is unit testing, then return something else, you're not Volkswagen, don't do it. If you have a general fixture, something that is shared between many tests, that's a problem. We already seen it in a different small. Then using resources like the database or HTTP in unit tests is a no-go. Unit tests should depend on no infrastructure. Do integration tests to test these connections. Indirect testing is also something that you should avoid if possible. That is, writing a high-level test to test some low-level business logic. So, for example, Magento integration test through a controller with which actually tests some business logic somewhere way lower, and yeah, with all the different input. So there should be one integration test that tests that the controller is working and returning something, but the low-level business logic should be tested as close to it as possible. And then there's inappropriate intimacy. I added it because I like the name, but it's also something that you should avoid. That is, if you access the privates of other objects. That's not cool anywhere, but for tests too. So avoid using reflection or something else to test private properties of your subjects on the test. You should always test against the public interface. As a conclusion, you can increase the maintainability and stability of your tests by taking care of the testing architecture. This is not all it takes, but it's one important part of it. Watch out for the typical problems I've showed you and try to get rid of them, and testing will be much more fun. Thank you for your attention.